Okay, so this one will be the AVL3 for the abstract data type. So for AVL3 is the one that can solve the problem of the binary search tree or binary tree. So you can see that for the AVL3, after we solve the problem of balance things, then the time complexity can be reduced. Okay, and it will be like a balanced binary search tree that we can reduce the time to search the value, and it will be balanced by height. Most of the time we're talking about the balance factors. This one is just one idea that if the left and the right, if you can search left and right equally step, then it will be balanced. So the balancing condition in the AVL tree is very important. So the balancing for the AVL tree that we're gonna concern is will be about the height. That will be the different height, the absolute difference between the height from the left and the right subtree. That's supposed to be less than or equal to 1. It's mean like 0 or 1. So it's mean that if it is less than 0 or 1 at that node, it means that it is balanced. For example, look at this one. The height of this node is, for the left side is 1, the right side is 2. So this will be height difference is 1. So this node is balanced. Node here, node 5 here. So the height is 1, 2, 3. And on the right side it will be 1, 2. So 3 minus 2 is 1. So it's balanced. Comparing to this one like node 7, the height of node 7 here is 1, 2, 3. The height is 3 and then minus 1. 3 minus 1 is 2, so it's not follow this condition, so it means that this graph is not balanced. So how to make it balanced, we will learn how we can rotate it. Okay, so we have left, left, right, right, left, right, and right, left. Okay. So here it represents that how is imbalance. Like I told you guys that at this point it's not balanced. Then we need to like rotate it at this position. Okay, this is the idea of the rotation. You can see that if it's imbalanced, like you have the weight from the left and the right from X, Y, and Z, and you would like to make it balanced, then you just change the node. Okay, like you wanna move B up. Okay, you're gonna move C up. So C is going to be the root, then this means that Y will be on the light subtree of A. So we have this properties that we can like rotate it. And for double rotation, so we have to rotate it. Here is A, Z, B. So we need to rotate between B and A first. So we will rotate this part first. So it will become B and C. Okay, and then we will rotate it from the B position to the left. Then is B will become the root, and then the balancing subtree will be like along with the A and C. Okay, let's see some example. Here it's showing, see how it's balanced or imbalanced. So you can see if it's imbalanced and you would like to make it rotate. So how to rotate it is like just a single rotation, and the position that imbalance is 1, right? Because at this position the height is 2 and here is 0. So 0 minus 2 is 2. It's imbalanced. So you need to rotate from this position to the left, and then it will become 2 as the root, 1 as left subtree, and 3 as right subtree. And here is the same thing, checking this node. This node is imbalanced or not. From the root, okay, check from the root is this one is balanced, this one is balanced, and this node is imbalanced. Okay, so if we found the imbalanced node from the root here at this position, then we need to rotate this to the left. So 4 is become the root, and then 3 is moved to the left subtree, and 5 become the right subtree. So this is the single rotation example. And here if they insert more number, like insert 6, then when they insert 6, you can see that they're gonna have like a single rotation that moving forward, and then 3 will be like go to the right sub t of true, and then yeah, 4 become the root, and then we add more at 7. So we shake, when we shake the balancing factors from here, 7, 6 here is balanced and this position is imbalanced. So what we have to do is at this position move to the left, then it will become like this. And then what they're gonna do is they would like to insert 15 and 14, right? 15 here, 14 here, and if you shake, 15 is still balanced, but 14 is imbalanced, right? So we need to do the the rotation. So 14 will become the root, okay, and then 7 will become like left sub 3, and 15 will become right sub 3. So it will be the double position at this position, right? And then they will move 14 to the middle, then 14 will become the root, 7 to the left, 15 to the right. So this is how we do the double rotation when we add the number and we found out that the node is imbalanced. Same here, insert 13, okay, and then we will see that here is the imbalance again. Okay, then we try to solve the problem. So we shake which position is imbalanced, okay, and if you see this one, you can see that this position is balanced, this position is balanced, this position is imbalanced here, right? So if this is imbalance here, okay, you see here is 0 minus 1, this is 2 minus 1, and this is like 1 minus 3, so imbalance at this position. And then we have this node, right? What we have to do is we need to move 7 up, so 7 become the root node and 6 going down, and 14 here. And the thing that belong to 14, which is 13 and 15, will like be the left and right sub 3 here, and 6 is just going down. So this is the double rotation of this one. So this is going to show you how we do the single rotation. Okay, we know that at this position is imbalanced. Once we have 3, add 2, add 1, and then we found out that the height here is 2 minus 1, right? 2 minus 0, which is 2, sorry. So it is imbalanced because it's equal to 2. Then what we have to do is we have to balance this one, and it will be like a single rotation. Same here with this, after it's balanced, we add 4. We add 4 here. And we add 5. Once we add 5, at this position is imbalanced. Imbalance at this position, then double rotate to the left. So you can see that after we add a single rotation, they rotate to the left, and then 3 is moving this way. Okay, add 6. At 6, we check the rotation. So it is imbalance at this position. This is 1 minus 3. So what we have to do is we will have a single rotation, rotate it, move forward to this direction from this point. So you can see that 4 right now is become the root of the image. And then what we're gonna do is add 7. When we add 7, we found out that here is imbalance again, 0 minus 2, right? Then we need to have a single rotation at this position and moving 6 and 7 to the left. Then this will become like this, okay? After that, we add 16. Then we have to check every single node that which one is the imbalanced one, right? Add 15. Once we add 15, we see that this one is 0 and this one, the height is 2. So 0, 2, here is the imbalanced position. Then we need to move 15 up to the middle, and then 7 to the left sub 3, 16 to the right sub 3, like this, as a double rotation. Same here, we have a problem again here. So the height is 1, 2, 3, and here is just 1. So we have a problem at this position, and this is imbalanced. Then we need to move 7 up. Okay, we need to move 7 up to the root, and then move 6 to the left, 15 to the right, and then balancing these 3 like this. Okay, so this is how we can balancing the AVL 3.